So, alright, students, we are actually going to continue on the USART related registers. So, previously we have seen what are the pins that are related with the USART, which is RC6 and RC7. And next, we're going to look at what are the related registers. So, you have the transmit, so TX, transmit status register. You have the transmit register. You have the receive status register. You have the receive status register, you have the receive register, as well as the baud rate generate register. So these are all the registers which are related to USART communication. Okay. So this is actually on the transmit status register. So under the transmit status register, if you look at the configuration, so you have let's look at the clock source. The first one, this is clock source. If it is in asynchronous mode, you don't care. So in most of the current situation, we actually use the asynchronous mode, not the synchronous mode. So you see that it stands for synchronous, asynchronous, transmit, receive. But most of the thing that we use now is UART, which is only asynchronous. So synchronous, we don't use that much, but that option is there. So in most of the time, if it's asynchronous, don't care. So we can always leave this as 0. And you can see the next one, which is 9-bit transmit enable bit. So usually this one we use 8-bit transmit selection. So this one always will be 0. Next, we look at transmit enable bit. So whenever we want to transmit, of course, we want to make it 1. So this one will be 1. The next one is the sync, USART mode select. So if most of the time we are in asynchronous, it will be 0. So we'll leave at 0. So number 3 is don't care. So we have 0. Then we see high baud rate select bit. So under asynchronous mode, if we are using low speed, then it will be 0. If it's high speed, it will be 1. Okay, so these are the values that we need to, depends on the question. If it says transmit asynchronous in asynchronous mode and high speed, then we should select 0. If it's high speed, then it should be 1. So this one depends, it could be 0 or could be 1 depending on the question. Then this one, you have the transmit shift register status bit. So this is the transmit register that we can actually also, whenever it is 0, it means that the transmit shift register status bit is full. That means it is ready to be transmitted. So this is the transmit status bit that we use to check whether is the data ready to be sent. If it's ready to be sent, it will be 0. If it's still showing 1, if it's 1, that means it is still empty. And of course, the last one is transmit 9-bit data. So usually this one also will be 0. So usually this part, the transmit is always will be 0 to indicate that it's ready to be sent. So the only thing that you will see that will have different value is this one. So this is on transmit status register. This is on the receive status register. So this under the receive status register, we look at the S pen serial port enable. Usually this is one will be 1 because we want to enable the serial port. Others, this is 9-bit, we don't use. The others all usually will be 0. All the others by default will be 0. We only focus on this one for the receive status register. So now when let me see what's the next slide. Okay, this is on the calculation. So currently you have the two register, right? One is on the transmit status register and also the receive status register. Okay, so this transmit status register will indicate whether is it ready to be transmitted, and the receive will enable the serial port to receive. So you have this transmit register. So inside this transmit register is where the data will be loaded. When the transmit register data is fully loaded, then you can actually see that this one will become 1. Okay, the transmit register. So when they becomes not becomes 1, becomes 0, indicate it's ready to be shifted. Then you have the receive status register, which is this one. So this one, just now how we showed, we only focus on enabling the serial port. So when a data is sent from here, it will be sent to the receive register. So the receive, this is important, that you need to know that where the receive data byte will be stored, the receive data byte will be stored in the receive register. This is important for you to know. So how to know now whether have we received the register or not? So just like how timer has flag, right, there is also this receive register. Let me see if we have, where's the instruction set? Just hold on. Series and files. Okay, so let's check the PIR register, because when the data is received, how we actually know or have the indication. So there is a flag. So let's look at PIR1. Where is it? PIR. Yes, if you look at PIR1, this is PIR1, right? You see that there is this RCIF. This is receive flag. So this is receive flag is what actually used to detect whether an incoming data has been received or not. So let's say if you want to know how does it know from the transmit status register, it actually indicates whether it's ready to be transmitted or not. Inside the transmit register is where we actually put the actual value, and once the value is there, the status will now change to 0, then indicating that the data can be sent. So from the transmit register, it will now send to the receive register. So the incoming data will be stored in the receive register, and what happens, your RCIF flag will become 1, indicating that the data has been received or has arrived. Okay, so this is how these 4 registers actually work. Is that okay? So this is important for you to know. For this register, baud rate generated register, we will see in the upcoming example how this register is actually being utilized. Basically, the value inside this register will determine the baud rate. So you can see that the shift clock for the USART is generated by the baud rate generator. So that is the SPBRG. So this is the formula that actually you need to know. So this one, you can focus on this one. This is the formula. Ideally, what we want to do is we actually want to find out what is the value of SPBRG. So there are 2 conditions. One, it could be in asynchronous mode, or it can be in synchronous mode. If it is in a synchronous mode, then this is the formula, which is in order for you to find out what is the content of SPBRG register, the formula is frequency oscillation divided by 4 times baud rate minus 1. And if it's in asynchronous mode, that is 2. Remember, in asynchronous mode, there is actually high speed. If it's 1, it is actually high speed. If it's 0, it's low speed. So the only both of the formulas look the same. The only thing different is this one. If it is actually high speed, then it is 16. If it is low speed, it is 64. That's the only difference. So let's see, this is the formula that you need to memorize. So let's see this particular question. It says compute the value to be returned into the SPBRG register, right? And what are the things that's already given? I don't know why okay, here it looks a bit nasty. I'm not so sure why the PowerPoint looks like this. But here the baud rate is given. They say for asynchronous mode, and he said high speed, and the frequency is given. So you know that there is 2 formula, right? There is one in synchronous mode, second is synchronous mode. So because the question mentions asynchronous, so you don't look at this formula of synchronous. And because you say high speed, so we will be looking at this one, right, which is SPBRG register is actually equals to the frequency oscillation divided by 16 times baud rate minus 1. So this is the formula that we'll be using. So you can see here. So what is the frequency oscillation is already given, 20 megahertz. And because this is high speed, we use 16 times given baud rate and minus 1. So you get this value. So this value is 128, which is the value to be returned into this SPBRG register. Okay. So in order for us to actually calculate what is the actual baud rate, so using the same formula, in order for you to now find what is the actual baud rate, is you use the same formula, but now you substitute the value of SPBRG inside, which is 129, and this one you want to find out. So when you manipulate, then you will get 20 megahertz over 16 times 130. So you get this one. So this is the actual baud rate that you will get when you load this value 129 into the SPBRG register. Even though the question actually asks 9600 baud rate, right? So you can actually find out what is the theoretical and also what is the actual calculation. So this formula is just to calculate the percentage error from what is wanted and what is being generated. So it's only 0.16 percentage error. Of course, the same thing you can actually use baud rate by using a low speed. If low speed means it's using 64. So again, the same thing, way of calculation. So you see that if you use the low speed, the error rate is higher. So what you can actually deduce from here is that when you use the high baud rate when you use the high speed, it gives less error. When you use the low speed, it gives more error. So this is something for you to actually know. So the important thing here is that to know this part, this formula. This is the important part that you all need to know. So this one, we are not going to do the programming part for this. But let's just look at it as well. So this is actually writing a subroutine to configure the USART1 transmitter to transmit data in asynchronous mode using 8-bit data format, disable interrupt, set baud rate to 96 and assume frequency 16 megahertz. So here you can see that we are writing the value of 24 hex 24 into the transmit status register 1. Why is this 24? Is because this part is 2 and this part, when you choose high, it becomes 4 hex 24. So that's why you see that it moved 24. And then this value 103 is the calculation. If you do back the calculation, you get this value because now the frequency is different, right? So you can actually use the same calculation for the high speed calculation to find out this value, baud rate. So you'll get 103, and this one you want to actually load into SPBRG3. And this part, what we are actually doing is configuring RC7, which is the receive pin, as an input, and we clear RC6 because we want to configure it as transmit, which is output. And of course here we are disable the transmit interrupt because the question says you disable the interrupt. And here we actually enable USART 1. Remember that under the receive status register, that is this S pen. So when you enable the USART, then the USART will be able to work. So these are the configuration, which some of it we've already seen in the earlier register configuration when we did this now. This example is actually very important. This is definitely very, very important. So here, study the instruction sequence below and compute the baud rate. So we need to find what's the baud rate. Assuming the crystal oscillator is running at 16 megahertz. Okay, so let's see what information we have here. You can see that 24 is written into transmit status register 1. If 24 is written to transmit register 1, what it means? That means this is, of course, you enable, and this is 1 means it is high speed. It's high speed. So with that, we'll know what formula to use. So this one, we know that it is high speed. And because this is 24, because this is 7, right, 0. So this actually means it will be in asynchronous mode. Oh, sorry, not that one. Where is it? Yes, sync number 4. If this one is 0, not 7, number 4, bit number 4, this one. If the value is 0, it already shows that we are in asynchronous mode. So we know we are in asynchronous mode. So we know we are async. Sorry, that's my, oops. Why is it so thick? Hold on, This is asynchronous mode. Okay, asynchronous mode, then we have the frequency oscillation at 16 megahertz, and we also have the value to be written to SPBRG register, right? So the X in the formula is actually hex 33. So we can see here it's enabled here, and this is shows that asynchronous. So we are going to use this formula when it is high speed, right? So you're going to use frequency oscillation over 16 times the baud rate. So we already have the baud rate value. We're supposed to find what's the baud rate value. You already have this one and we already have the SBBRG register value. So yes, we can find out what is the baud rate. Hey, what is this? So you can actually convert this value hex33. You need to convert it to decimal value. So before you do the calculation, you convert it to a decimal value, then you substitute the frequency oscillation, use 16, then you'll be able to find out what is the baud rate. So this is quite relatively simple. Important thing is, remember to change this hex value into decimal. So make sure you know how to do this example. All right, so with that, we are done with this chapter 9. Sorry, there's another one more example. We'll finish this. So here is, if you have one character transmitted by RS232 using the format of 8 bits, no parity bit and one stop bit. So how long does it take to transmit the following message at the speed of 9600? Show the calculation. So here is the message that you want to send, and there is a space. There's no other character between here and also here. Oh, sorry. So here how we actually do the calculation is, first we actually try to find out, in order for us to transmit one bit, how long does it actually take? So what is actually baud rate? Baud rate is the number of bits per second. So when we say 9600 bit per second, bits per second. So if we set as the baud rate as 9600, it means that in 1 second it can send 9600 bits. That's why BPS, bits per second. So now we want to find out how long does it take to transmit one bit. So simple maths is 1 over 9600. So you can see that in order for you to transmit one bit, it takes 104 millisecond. So what is the total number of bits? Is of course total characters multiply bit. Always we have one start bit by default and 8 data, and the stop bits is always not always, sometimes can be 1, sometimes can be 2. So in this case it's 8 1. So how many characters are there in total? There are a total of 33 characters. So each character has 8 plus 1 plus 1, 10 bits. So in total you have 330 bits for all this character. So because you've already calculated how long it takes to transmit one bit, so you just need to multiply and then you'll get the answer. So the total time to transmit this entire character is 34.32 millisecond. Okay, so we'll end here at this chapter.